Yes, class, is it audible?
Yes, ma'am.
Fine. So in the last class, we had our last class on Saturday. So what all we had discussed? We had discussed this series and parallel combination, right? This is what we had discussed. Yes, Faiza, what was the formula for equivalent capacitance in series? Faiza. We had done this, no? In the last class. If C1, C2, C3, these are your individual capacitances, then what is the equivalent capacitance formula? Austin.
1 by C is equal to 1 by C1 plus 1 by C2.
Yes, 1 by C equivalent is equal to 1 by C1 plus C2. Humam, in parallel connection. Yes, Humamuddin.
C1 plus C2.
C1 plus C2. In series, you directly add them. C equivalent will be equal to C1 plus C2. That's it. Fine. So this is what we had discussed in basic circuits we had discussed. Now in today's class, I just want to wrap up this lesson. Though everything we have completed, but some more circuits I want to discuss with you. So see, for example, this question only. We had seen the question where only one case we got. Either it was series combination or it was parallel combination. So look here. This is one capacitance. This is second capacitor. This is your third capacitor, right? So second and third, you can see branching is here. It means they are connected in parallel. So they are connected in parallel. If they are connected in parallel, so C2, 3 means they are 2 and 3. They are connected in parallel. So C2, 3 equivalent will be, so right now only Humam has answered that it becomes C1 plus C2. So here also, what is the first capacitance? This is 5 microfarad and this is 10 microfarad. So that becomes 5 microfarad plus 10 microfarad is equal to 15 microfarad. It means instead of drawing this entire circuit, you can just draw one capacitor with this capacitance, right? What is the meaning of equivalent capacitance? That you can replace those capacitor with this single capacitor. This is what is the meaning of it. So it means if I want to draw, this was 10 microfarad already. Now, instead of drawing that parallel component, I can just replace it with a single resistor of resistance micro 50, not resistance, capacitance 15 microfarad. Fine. Now see, this was 1 and this is 2, 3. 2, 3, we have combined 2, 3. Instead of writing this separately, we have just combined them. So this becomes, they are connected now in series connection. So if they are connected in series connection, one by C equivalent will be 1 by 10 microfarad plus 1 by 15 microfarad. So C equivalent will be 15 into 10 divided by 15 plus 10. That becomes 150 by 25, which is equal to 6 microfarad. So the entire capacitance of this circuit, this is 6 microfarad. Now class, if something else is asked to you, like what is the total charge? So total charge will be total capacitance that has come multiplied by total potential. Total potential is given 10. So if total charge is asked to you, total capacitance is 6 microfarad multiplied by 10 volt. That gives you 60 microcoulomb. Like this, you can calculate rest of the quantities which are unknown. Noted down, some more circuits we'll see. Those who have written till here, try this question. Start from here. Then keep on moving like this. Keep on reducing your circuit. And all the capacitance's value is C. Yes, any answers? See, let me mark these capacitors. Let's say this is first, second, this is third, fourth, this is fifth, and this is sixth. All are identical. Now see, what you can see from here, this capacitor and this capacitor, both of these, they are connected in series or parallel? First and second? Parallel, right. They are connected in parallel. Because you can directly see here branching is coming. So both the voltages will remain the same and the charge will divide. It means first and second, they are connected in parallel. So C plus C, what will be the equivalent capacitance for the first one? It would be directly C plus C, that is 2C, right? So see, this means 1 and 2, they are connected in parallel. So C12 means if I combine 1 and 2, this will become C plus C, which is equal to 2C. Now see, instead of capacitor 1 separately, capacitor 2 separately, I have combined C1, C2, right? I have combined C1, C2. So this is how the circuit will now look like. See, rest of the things are same. 3 is here, 4 is over here. Look, 4 is here, 5 is here, 6 is here. This was our A point, this was our B point. Instead of C1 and C2 separately, now this is C12, whose value is now 2C. The value is not C, right? Now, coming to this. Look at this. How are they connected? Yes, Tarif. Series or parallel? Yes, Tarif. Tarif, you're present. Rabia,
Yes, ma'am. Parallel.
why parallel? Reason? One capacitor is like this, another capacitor is like this. How are these two connected? Rabia. It's series. Yes, Faiza and Humam, right. See, this is a single wire. I have told you in the last class, that's why I told you that please remember all the basics thing. The wire, we have just bent the wire. Charge will flow the same. There isn't any branching between these. We are not talking about this. We have not included this because there is a branching here. Answer will be different. We are just talking about 3 and this. This is a capacitor with a single wire that is connected with another capacitor. If you have two capacitors connected with a straight wire, there isn't any branching. So how can you say they are connected in parallel? They are then connected in series. If there isn't any branching, if you see another wire is getting added, or you see the charge is getting divided, how can the charge get divided here? This I have made you write. Remember this type of question also, this type of example also I had given you. If charge is flowing, if you bend the wire, charge will still be Q. Is it clear, Rabia? Why will it be in series?
Yes, ma'am.
Okay. If you see any branching, then only your parallel connection comes. Otherwise, there are different cases which we will see later. So they are, it means 3 and 1, 2. C3 and C12. They are connected in series. Now, if they are connected in series, so 1 by C123. I am just writing 1, 2, 3 like this so that at least we are familiar with which capacitors we have combined. So this becomes 1 by C12 plus 1 by C3, right? This plus this, 1 by this plus 1 by this. So C123, this will be 1 by, this was 2C plus 1 by C. So if this becomes 2 plus 1, 3. So 1 by C123 becomes 3 by 2C. So C123 becomes 2C by 3, right? So now instead of these two, what you can combine and write it like this. This is now C123, right? C1 was there, C2 was there, we combined it, we got C12. Then C12 and 3, they were in series. Now we combined and made a single capacitor, which was C123. Now C123, this is now one single capacitor whose value we have obtained is 2C by 3. The rest of it we know. This is C, this is C, this is C. This is 2C by 3. Now this and this. Faiza. How are C1, 2, 3 and 4 connected? Parallel. Very good. They are connected in parallel. So your C4 and C1, 2, 3. C1, 2, 3 basically means all the 3 capacitors which we have combined together. When all these are combined together, we write it as a single capacitor. So they are connected in parallel. So C1, 2, 3, 4 means equivalent capacitance of all this 2C by 3, not plus 4. 4 is not the number. C, capacitance value is C, Pfizer. 4 is just I have marked the number of capacitors that we have so that I can refer to it because all were identical. All right, yes. So that becomes 2C by 3 plus C, which becomes 5C by 3, right? Now C1, 2, 3, 4, I have obtained it as a single capacitor. Now I do not have these two separate capacitors. This is a single capacitor. So I can replace this by a single capacitor. Now you can see we just have 5C by 3. This is what? If I start naming it, this was C1, 2, 3, 4. All the 4 we have combined. This was the 5th one. This is the 6th one. This value is 5C by 3, which we have obtained. This is C. This is C. Yes, Shahid. How are these 3 now connected? Series. They are all connected in series. Good. So if they are connected in series, means 1 by C equivalent. Now this is the final answer. 1 by C plus 1 by C plus 3 by 5 by C. Perfect, Faiza. Good. So 1 by C equivalent will be 1 by C. I'm writing it not it as 1, 2, 3, 4, 5 because this is the final answer. So no need to write it separately. So 1 by C plus 1 by C plus 3 by 5C. So 5, 10, 13. 1 by C equivalent, this is 13 by 5C. So C equivalent becomes 5C by 13 farad. This is your C equivalent to the resistor, which this was our actual circuit. So if we connect, whenever, no, one more thing class, if the question says equivalent capacitance between 2 points, then what you do, if A and B, these are points, just imagine you have connected a battery. Now this will appear to you as a circuit if somewhere you are having confusion. If not, like this was an easy question where you could keep on solving it. But when it is saying equivalent capacitance, it means capacitance, there is an imaginary battery that will help you in your calculations, nothing else. Fine, note it down. One more thing, class, you have your test this Friday. So the portion of physics is this lesson. Potential you have already given. Capacitance is left. So potential and capacitance both, I think, because potential you have already studied. And this portion of capacitance, more questions of capacitance will be there. Potential, you people have already appeared one test where electric field and charges till potential came, right, in the last test. So capacitance was left. So capacitance with this lesson means chapter 2 is the syllabus for this Friday's exam. Fine. I hope it's fine to all of you.
Yes, sir.
Three by 11C. Final answer. This 5 into 5, 10 means this is here we will multiply it by 5. Here we will multiply by 5. So 5 plus 5, 10. 10 plus 3, 13.
Yes, ma'am. Yes, ma'am. I
Right?
took it as 5 by 3.
Yes, one more thing, class, that comes in the exam. See, sometimes our circuit appears that these are connected in parallel, they are connected in series. But if you look at it properly, you will notice that no current is flowing through it. For example, look at this. When do we call the circuit as a short circuit or an open circuit? See, this is a wire, this is a bulb. Fine. And we have the cell connected here. Now what is happening? I have connected a wire across this bulb. It means the bulb was like this. I have connected a wire across this. So what happens? The current, instead of passing through the bulb, the entire current finds its path through this and goes. So in such cases, was there a difference if the bulb was connected or not? There isn't any difference. Even if you connect the bulb and if you do not connect the bulb, nothing is happening. What will you do? If the bulb is connected, the bulb won't glow here because the current isn't flowing, so the bulb won't be glowing here, right? So instead of drawing all this, what I can do? I can draw a single wire. When this is what is meant by short circuit. So this was in case of bulb. The bulb you all will see later in current electricity. See right now, if a capacitor is connected here, charges are flowing. Charges are flowing entirely. So instead of passing through the capacitor, the charges flow through this wire and complete their path like this. Fine. Now see, instead of drawing this entire part, I can draw it like this also. Same thing is occurring. Charge is moving and charge is coming back, right? Was there a difference if I connected the capacitor? Was there a difference when I connected the bulb? There wasn't any difference when I connected these. Why wasn't there a difference? Because no charge is flowing, no current is flowing within them. In these cases, we call them as short circuit. Short circuited, this term you must have circuit. The circuit has been short circuited. Now, one is short circuit, another is open circuit. So if this is a case, like in current is flowing, right? Current is flowing in across a resistor and a wire is connected like this, you can replace it with a single wire. Similarly, in this lesson, particularly in this lesson, you will be having capacitor. In any circuit, if you see a capacitor is connected and a wire is connected, that means it is short. You can draw it like this. Note down
Short circuit
this.
means there is no current.
Yes, Chavez?
Short circuit means there is no current in the capacitor.
Short circuit means a circuit is connected, but the wire that is present, the wire that is connected to you, that the current or the charge is entirely flowing through it. So you can replace it. This is what you're asking, no?
Yes, sir.
You can replace it. As in, right now you didn't see any question. Later on, I'll make you see. Suppose if this is a question given to you. Fine. This is one capacitor, this is second capacitor, this is a third capacitor. This is made. So you don't need to solve this in your circuit because this is short circuited, means no current will flow through this, no charge will flow through this. Your only answer will be these two. This is how it helps you in solving your questions, the questions that will come in your exam. Sometimes if a wire is given across like this, across resistors, across capacitors, across inductors, there this becomes a problem. Then it helps in cancelling out the device. Okay, note this down. One more thing, you have open circuit also. Open circuit means when, see here, when lots of current was flowing, we called it as short circuit, right? If no current is flowing, but there is an, see, short circuit, lots of current was flowing through the same wire. In open circuit, there is a breakage. This is what we call as open circuit. So in open circuit also, you have your the current as zero, no current is flowing. But this we'll see later on in detail. Right now, just write about short circuit. Yes, class. See, sometimes what happens, you see the circuit arranged in this manner. Now, if you see some circuits which are more, these circuits are usually given in resistors, but these can be given in capacitors as well. So C1, C2, C3, C4, these are 4 capacitors that are connected, and one capacitor is connected across, which is the C5. This is connected across. This is 5th. Fine. And from A point to C point 1, battery is connected. Now, look here. C1, 2, 3, 4. If you identify out of these, can anyone tell me which are connected in series and which are connected in parallel? Anyone? Like 1 and 2 are connected in series, 2 and 3 are connected in parallel like this. Yes, Chavez.
C1, C3 and C5, C2, C4, these 3 are connected in parallel.
C1, C2, C3, C4, all these 4 are connected in parallel.
No, like C1, C3 and C5 is connected in parallel, and C2 and C4 and C5 is also
These
connected.
3 are connected in parallel, you see.
Yes,
See, if these 3 are connected in parallel, it means I can replace this with a single resistor, right? So this, it means instead of writing of all these, you can replace this by a single capacitor, right? When you're saying, no, these are connected in parallel, it means you can replace all the capacitors with a single capacitor. So see, if you keep these and replace it with a single capacitor, then also this will be stuck in this wire. C12 series, 3, 4 series. Then
C5 there will be no current, right?
yes, C34, C12, and C5 in parallel. Austin, see, C1 and C2, how can they be connected in series? Directly, you can see a branching is there. Any other answer? See, Austin, you tell me. There's a branching, no? If a current will flow, charge will flow. In this case, it will move here. 2 different charges will be there. Anyone else? Any other answer? See, there isn't any actual right answer, because see, all of you have also tried. Like Chavez also answered, like these 3 could be connected in parallel. But then when the resultant comes, when you connect this as a single capacitor, then further you cannot solve. If we go by Austin's method, here suddenly we see a junction. So either ways, you cannot find a perfect connection of series or parallel connection, right? So what we do, this case, this case, when you get stuck and you see 2 capacitors are connected like this and 2 capacitors are connected like this with one more capacitor connected across. This setup is known as Wheatstone bridge. Fine. Now, if bridge is balanced, there's a balancing condition. I'll tell you right now only which is the balancing condition. If the balancing condition is achieved, if there is a balancing condition, I'll tell you what is that condition. Then potential difference across this edge and across this edge remains the same. Whatever is the potential difference, VB is equal to VD. So if potentials are same, what will be the difference? 0. There won't be any potential difference. So potential difference across this becomes 0. No charge flows through it. Now you can remove it. In your circuit, you can remove it. There isn't charge any flowing. Try to identify Wheatstone bridge, because if you are able to identify Wheatstone bridge, calculation part is very easy. See class, if the potential difference is 0, it means this wire is not present. Now can all of you, anyone, tell me which are connected in series, which are connected in parallel? How can we solve it now once that is removed?
C1 and C2 are in series.
C1 and C2 are in series, C3 and C4 are in series. You can directly see
All of
this
them
is
are
a single wire. Yes, they are resultant, and then C12 which will be obtained and C34 which will be obtained, they'll be connected in parallel. Now this is a very easy question, but when we had this, we weren't able to do with any method. You have another method which is known as Kirchhoff's method. That is particularly for, we'll see that in the next lesson, Kirchhoff's method. By that you can solve it, that's a different thing. But if you are able to identify this setup of Wheatstone bridge, you should be able to solve it, because the solving part is very easy. You could see, no, these were connected in series, these were connected in series, their resultant were connected in parallel, right? This was like, here they are connected in series, and here also these two capacitors are connected in series, and their resultant, they are connected in parallel. This was the condition. So this is one more method to save up your time, because directly students, what they will do, they'll perform the entire Kirchhoff's method. That is a very lengthy method. Answer will be the same. So what you have to remember, directly you can put this up. Now, what is exactly the balancing condition? Balancing condition is mainly, so you have to first check up for the balancing condition. If your Wheatstone bridge is balanced, then only you will solve this. If it is not balanced, do not apply this. Fine. This is for balanced Wheatstone bridge. So to decide whether your bridge is balanced or unbalanced, balancing condition you will check. All this will come again. We will see this in detail if through resistors, because usually these are given less for capacitors. But just in case if you have for capacitors, you should know this. So C1 by C2, C1 by C2 should be equal to C3 by C4. This is the balancing condition, C1 by C2. So you will check. Suppose here you have 3, 6, here you have 2, 4. 3 divided by 6 is half. 2 divided by 4 is also half. Half is equal to half. You have the balancing condition. You can straight away remove your midway capacitor and directly take them in series and add them in parallel.
And so potential between B and D will be 0. So if it is this.
Potential will be there, but the potential's magnitude will be same. So its difference will be 0.
Okay.
All right. It's like 5 volt and 5 volt. So what is the difference? 5 minus 5, 0. And if potential difference, because we do not talk about potential. Single potential is associated with a single charge. But we are not talking about single charge. We are talking about multiple charges. There we consider the entire difference, the potential difference that comes in your circuit. Fine. So potential is there. Potential will be there because the battery is connected. If you have connected it to the battery, potential is there. But if this condition is achieved, all these are done through experimentally. Lots of data were obtained, and this was observed that when this condition was achieved, potential came out to be same. So through that, it was concluded that potential differences. Fine. So note it down, and whenever in your circuits you have Wheatstone bridge condition, try to identify it. This we'll do again. And we'll do the derivation also. How this balancing condition is achieved. That is also there. That also we'll do. See the diagram of Wheatstone bridge. One capacitor is connected here, another capacitor is connected, right? This is one capacitor, here is a second capacitor. Now this branching, there are two branches. One branch is C1 was there, from here one branch C2 was there. From here in one branch C3 is present, from here in this branch C4 is present. So these four are connected in a rhomboid manner. Now across this, and be careful class, sometimes it becomes confusing. This is given. These are given, these are the four capacitors which are given. Sometimes this is mentioned, and here you have. So this is not your Wheatstone bridge. This is, you can easily solve. They are connected in series, and all the three are connected in parallel. This is different. So always remember, from BD you connect the circuit. So across this BD you have this potential same, this same, means VP is equal to VD. So there isn't any difference. This branch gets cancelled out. Means what you can do, instead of drawing this, your actual circuit will appear to be like this. Now, see, you have a section where this is particularly for capacitors. This you won't see for resistors. Fine, this can come from your capacitors. So these are problem involving plates. Yes.
Can you scroll up?
So when you have problems involving this portion only, Shavesh?
Yes, ma'am.
Okay. Now, if you see plates are connected with opposite polarities, now positive and negative charges, these you have to keep in mind, whether the charge plates have acquired positive charges or they have acquired negative charges. Fine. So if you see opposite polarities are connected, then it means they are connected in series. If you see the same polarities are connected, it means they are connected in parallel. But let me show you the written, Shavesh.
Yes, ma'am.
See, for example, you have this question. This is one question. Calculation part is not there. You just have to understand. I have to find out the equivalent capacitance between A and B. So I will connect them. See, A, this is positive terminal. Suppose this is negative terminal. Any of your terminal you can make it. Suppose I have made this as positive, this as negative. So what will happen, class? Look, if this is positive, so the plate that is connected through it, this plate. This will entirely be positive because it is connected towards the positive terminal. So this will have the positive charges. This side also will have the positive charges. This side will have the positive charges. This plate, this entire plate has acquired all the positive charges due to this positive terminal. And since this plate is connected to the negative terminal, entirely this will be acquiring the negative charges. Means all the negative charges are present on this plate. Now, if opposite polarities are there, how do we construct a capacitor? What have we studied? How to construct a capacitor? When a positive plate is connected with a negative plate, if two negative plates are connected, will that form your capacitor? No. What was the condition requirement in earlier when we had studied regarding capacitors? We had seen two plates or two conductors of opposite charges. Till the time they won't have opposite charges, we won't be able to construct our capacitor, right? So if positive, one plate is having positive edge, another plate is also having positive edge, our capacitor won't be formed. If one is having negative, same is having another negative, it won't be formed until and unless you have one positive plate, one negative plate. See, this is the positive plate, this is the negative plate. This is your one capacitor that has been formed. Let's say the separation between them is D. Negative plate, positive plate. This is small d. It means another capacitor has been formed. Come here. Plus, this is negative. Another capacitor has been formed. How many capacitors we have? 1, 2, 3. 3 capacitors we have formed. Your equivalent capacitance will become 3 epsilon naught A divided by D. Directly, this will be your equivalent capacitance. If you have problems involving plate, directly your answer becomes this. Clear? You have to form capacitors. Suppose here this capacitor wasn't forming. Suppose, let's say. So my answer would have been 2 epsilon naught A by D. If only one was formed, so epsilon naught A by D, like this. There isn't any modification that is asked from this. Fine? Note down this. Problems involving plates. One more question I'll make you see from this only, so that this part gets clear. No, D is the separation between the plates. The way we take in our formula, epsilon naught A by D. A is the surface area. D is the, yes, D is the separation between the plates. Same thing, that formula only. Is it compulsory to have the same number of positive and negative in the plates? Same number? No, it's not necessary. See, in your question, no, I'll show you the next question, that then your doubt will be cleared. It's not necessary. You can have any type of question in the exam, but you have to just consider those which are forming positive and negative. It doesn't matter if in your circuit none of the plates are forming one positive and second negative, then it means zero. No equivalent capacitance is there. Even if one plate is formed, your answer will be epsilon naught A by D. 2 plates, 2 epsilon naught A by D. 3 plates, 3 epsilon naught A by D, like this. 4 plates, 4 epsilon naught A by D. N epsilon naught A by D is your answer. N is the number of plates. But it's not necessary. You can have any type of question, but you only have to consider those. Let me show you. Have you all written this?
Yes, sir.
Completed? Okay. One question, let me show you. See this. These are two terminals. Now look, when I will connect a battery to both of these, this is one positive end, this is the negative end. So the plate which is connected with the positive, this will acquire positive charge. This plate will entirely become positive. Fine, because this is connected to the positive terminal. If we connect this to the negative terminal, this plate will entirely become negative. This plate will become negative. Now coming to our calculation, which plate will be formed or not. Positive end, negative end. Will there be a capacitor plate formed or not? Yes or no, according to you all?
Yes, sir.
Yes? Yes, it would be formed because one is positive, one is negative. Separation would be D. This is our capacitor. Will there be a capacitor formed over here?
Yeah.
Yes, Chavez?
No capacitance is there.
Capacitor won't be formed. Shahid, Faiza, no. Yes, there won't be a capacitor formed. See, this is also negative, this is also negative. So Tarif, see, in the last question, you were asking no, whether it's compulsory to form a positive and negative plate. Look here, automatically, this is not coming positive and negative. So it doesn't matter. I won't consider this in my calculation. I'll leave it as it is. That's up to you, not considering it or not considering it. So I leave it up to here because this is not a capacitor form. Question can be anything. In the question, it can be positive forming, it can be negative forming, it can form you a proper capacitor with opposite polarities, it can form two plates with same polarities as well. So that is not necessary. That is not compulsory, which you were asking. Now coming to this. Negative, positive. Now there will be a capacitor formed. So what should be the value of C equivalent? Type it in the chat box, all of you. What should be the C equivalent now? Yes, class. Quickly type it in the chat column. Shahid and Austin have answered. Tarif has also answered. Very good. 2 epsilon naught A by D. This was one plate form. This was second plate form. There wasn't any plate that was formed. Yes, Shahid. 2 epsilon naught A by D. This is how the questions, these types of questions you have to manage. No doubt this. This is exclusive for capacitors. This won't be repeated in your resistors. Done.
Yes, ma'am.
One
Yes.
last type of case I want to show you that is also exclusive for capacitors only. The way these plates, problems involving plate, this won't be repeated anywhere. Wheatstone bridge will come. Rest of the questions will also come. Rest types of circuits will also come. But problems involving plates and dielectric slab, these won't be repeated because dielectric slab are also for your capacitors. See, this what you remember here. If you have dielectric slab, if your area is getting divided, suppose the dielectric slabs are placed here, no, in this case two different dielectric slabs are placed and you have to find out the equivalent capacitance. So always remember, when dielectric slab is placed, area is getting divided, then they are connected in parallel. And if your distance means separation between the plates is getting divided, then they are connected in series. For example, look at the first question. K1 is the first dielectric constant K1 and K2 is the dielectric slab with dielectric constant as K2. Separation between them is given as D. Now see, because presence of dielectric slab, the area is getting divided, right? Area of the plate is getting divided. So area getting divided means they are connected in parallel. If K1 is the constant, A by 2 is the area. What do we have as our general formula? We have studied, no? This formula only we have studied. K epsilon naught A by D. This was the formula when dielectric slab is there. So what will be C1? K will become K1, epsilon naught, A becomes A by 2 by D. Similarly, C2 will become C1 will become K1, epsilon naught, A by 2 D. C2 will become again K2, epsilon naught, A by 2 and D. Right? These will, what will they become? So how will you add it? They are connected in parallel, so you can directly add C1 plus C2. This you can add it directly. C1 plus C2. This I have written this, so no need to write this. Now look, when you will add it directly, this becomes K1 epsilon naught A by 2D plus K2 epsilon naught by 2D. Epsilon naught by 2D you can take common. K1 plus K2 is left within the brackets. This you will be able to manage. This you will solve. What you have to identify, whether they are connected in series or parallel. One more thing. How to identify whether they are connected in series, they are connected in parallel, this we could see. See if this is the case. Now see, in this case, your distance between the plates is getting divided. The area is as it is. Area of the plates is not getting disturbed. So what you have as your final answer, C equivalent, this will be, they are connected in series. So 1 by C equivalent is equal to 1 by C1 plus 1 by C2. So same thing, K1 epsilon naught A by D by 2. Here it is D by 2 in the formula. So when you add it up, this will go up in the numerator. What you are left with, see, these are the individual capacitance. 2 is going up because this is D by 2, right? What you can do, take D by 2 epsilon naught A as common. 1 by K1 plus 1 by K2 is left. This can also be your final answer. Or if you wish, you can take their LCM because we have to reciprocate it. No, 1 by C equivalent we are obtaining. We have to find out C equivalent. So 2 epsilon naught A, K1, K2 divided by 2 D, K1 plus K2. This is how you can solve. Note down these two also so that you remember, just in case if you see any question of dielectric slab. Okay, Pfizer, text me on WhatsApp. You have my number, no? I'll share you. Fine, all the important topics which you are mentioning, I'll share you on WhatsApp. I'll give you the heading of the topics. Otherwise, rest of the things I have already mentioned in the class. I hope you have the number, no, Faiz, or I have to reshare it. Now, see, these were the series and parallel connections which you have. And remember, when the capacitors are connected in series, whatever is the C equivalent obtained, no, that will always be less than the individual capacitors values. Like C1 plus C2, you can notice whatever is the C equivalent, this is less than what is for each in case of capacitors. Okay, fine. I'll reshare the number.
And this will come in exam.
Less chances are there for your CBSE exams. But just in case practice, if these circuits are given, these dielectric slabs can come more than the plates. These slabs can come. But if they'll come, no, they'll come these basics only. Usually you have the questions which we did earlier, those types comes. But these can also come, and sometimes they have repeated themselves. This also comes. Please text me done in the chat column once